Hey, welcome back. We got perpendicular lines today. Gonna be a real short, sweet video, not too much information, but again, important information as always. Perpendicular line intersects another line at a right angle. By now we should know that. You guys have known that probably for at least a year. Hopefully you should know that. Okay, so if we look at a picture like this, a little diagram, we want to name the shortest segment from P to MO. So we have three choices. Is it this, or this? Okay. Well, if you look at it, you know, and you probably already knew this, but PN has to be the shortest one. Okay, it's the most direct route. If you're going to go to your friend's house, you're going to take the most direct route to get there. If you were walking, or obviously roads don't always go directly, but you always want to take the direct route. Okay, so basically, perpendicular lines are going to create the shortest distance. Okay, so we would know that these are right angles. Part B, write an inequality to find the possible values of x. Hint, how can you compare the given information? Okay, so if we just said that that has to be the shortest route, then what we want to do is write an inequality saying that. So we want to say that that segment 7, length of 7, has to be less than, can't be equal to, but it has to be less than 2x minus 5. Okay, because that segment has to be shorter than 2x minus 5, that longer segment. Okay, from there we could simplify our inequality. So if 12 is not equal to, 12 is less than 2x, divide both sides by 2, so x has to be greater than 6. Okay, so if we plugged in 7 here, we would get 2 times 7 is 14, minus 5 is 9. So we're good. Okay, so it has to be greater than 6. I'd like you guys to try number 2. Okay, so again, name the shortest segment. That should be a pretty easy part, and then write an inequality just like we did on that last one. So make sure you have 2 done for tomorrow. A couple theorems to remember. We've already talked about them. I can draw you a picture so you can remember what it looks like. If two intersecting lines form a linear pair of congruent angles, then the lines are. So let's see what this looks like. So if two intersecting lines, okay, that form a linear pair of congruent angles. Oops, I want to draw that a little bit better. Doesn't look exactly like it should. Let's draw it that straighter. There you go. If they form a linear pair of congruent angles, so we know that these two angles have to be congruent to each other. Well, the only way that they can add up to 180 and be congruent to each other is if they're 90. So basically we know that those lines are perpendicular. So some of these you have to draw, just think about by drawing pictures, help you out. In a plane, if a transversal, okay, so we have a transversal, and it's perpendicular to, again, I drew that bad, should be more straight up. If it's perpendicular to one line, and we know that these two lines are parallel, it has to be perpendicular to the other line because they're going through at the same exact angle. Because think about it, if they're going parallel to each other, one's a right angle, the other one has to be a right angle. It wouldn't work any other way. Last one, if two coplanar lines are perpendicular to the same line, so we have two coplanar lines, and they're saying that they're perpendicular to the same line, then the two lines have to be parallel. So that's kind of the backwards one of the one before. Okay, so if two lines are parallel, and this one right here, if two lines are parallel to each other and one has a right angle, the other one has to. If we know that two lines are perpendicular to the same line, then the two lines have to be parallel to each other. Okay, so things you want to keep in mind. If we look at a couple more examples, okay, all going to be pretty simple things. If we know that angle 1 is congruent or equal to, there should be a little congruent symbol there. If angle 1 is congruent to angle 2, well, again, the only way for those to add up to 180 and be the same is that we have right angles. Okay, so we could say that angle 1 and angle 2 are right angles. Okay, pretty simple conclusion. If we know that angle 2, so let's get rid of this, angle 2 is 90, and angle 3 is 90, okay, think about what we said. M and N have to share something in common. What they share in common is that they're parallel to each other. So let's just actually abbreviate that as M is parallel to N. Think about roads. If one's cutting through at a 90-degree angle, the other one's cutting through at 90 degrees through the same road, then they have to be perpendicular. And then, in this case, parallel to each other. Last one. Let's erase this. If angle 2 is 90, so let's mark it as 90, and M is parallel, and the way we mark that is with those little arrows. If M is parallel to N, then we have to know that angle 3 is also 90 degrees or a right angle. Again, think about it. If we'll call this Grand Avenue. Okay? So if Grand Avenue intersects O plane at a 90-degree angle, it also has to intersect angle 3, or rather line N, at the same angle, which we've already said. We must know that that's the right angle. In other words, we could say what else is perpendicular to Grand Avenue besides O plane. We could say this is Milwaukee. Okay, so again, if one of them is a right angle and they're parallel to each other, the other one has to be a right angle. Okay, last one I want you guys to look at, solve for x and y. Okay, keep in mind, these lines are parallel. We have a right angle here. We know something about this angle. Okay, again, solve for x and y. That means you need to come up with the system, two equations. Okay, you can use the equations more than once. Okay, you want to make sure you don't come up with the same exact one, obviously. So think about what you know about those two angles. Do you know vertical angles? Do you know supplementary? Do you know you have a 90-degree angle somewhere? So come up with those two equations, and I want you guys to try and solve this system for tomorrow. See ya.